the velocity reaction have a velocity constant is fixed, that is it is constant, and changes with temperature. That means velocity constant or the rate constant changes with temperature. I will see. I have discussed the velocity constant terms. This what are the characteristics of the velocity constant? First, it is the measure of rate of reaction. Greater the value of k, faster is the reaction. Smaller the value of k, slower is the reaction. Number second, velocity constant depends upon the nature of the reactants. That is, each reaction has its own velocity constant, or we can say in other words, different reactions have different velocity constant. Number third, velocity constant is independent of the concentration and depends upon the temperature. At a fixed temperature, velocity constant is fixed and changes with temperature. These were the characteristics of the velocity constant. I will now we will discuss what is the velocity constant. How we can define the velocity constant. For example, I will write the equation here again. I will now here discuss the velocity constant. What is the velocity constant? I have written the general term A plus B gives products. As per the law of mass action, we have discussed it. Rate is proportional to concentration of A into molar concentration of B. I have written in square brackets. Now I will rate is equal to, I have used the velocity constant K, molar concentration of A into molar concentration, that is active mass of A into active mass of B. Now if I consider that molar concentration of A is equal to molar concentration of B, that means is equal to 1 mole per liter. That means A का 1 value है, दूसरे B का भी value 1 है. Then at that time, rate is equal to K. So here we can define the velocity constant. So velocity constant K can be also defined as rate of reaction. Yes. What have I have taken the concentration here? I have assumed the concentration of reactants as 1 mole per liter. So rate of reaction when concentration of the reactants is unity. This is the definition of velocity constant. You must remember that units of velocity constant is different for different order of the reaction. For different orders, you must remember it. Units of the velocity constant are different for different orders of the reactions. So I will write another equation here. For example, I will write here this m1 times of A plus m2 times of B plus m3 times of C gives products. So as per the law of mass action, we can write rate is proportional to A. Now here I have used the stoichiometric coefficients m1, m2 and m3. As per the law of mass action, it is each concentration term raised to the power equal to its number of moles in the stoichiometric equation, m1 into concentration of B raised to power m2 into C, concentration of C, molar concentration, raised power m3. This becomes the general equation of the law of mass action as per the definition that rate of a reaction at a particular instant is proportional to the product of the active masses of the reactants at that instant and raised to the power, which are numerically equal to the numbers of the stoichiometric chemical equation, stoichiometric number of molecules of the which in the stoichiometric equation describing the chemical reaction. So this is the law of mass action. That means m1, m2 and m3 terms, these are the stoichiometric coefficients raised to the powers. Now here I will write a general equation again. let I write it general equation. Rate A plus B gives products. Students, keep mind what I am going to say. So as per the law of mass action, I will write rate is equal to K, concentration of A, into concentration of B. Now if I will write here another equation, N times A plus M times B gives products, then I will write it is rate is equal to, as per law of mass, K A raised power N, B concentration of B raised power M. This N and M are stoichiometric coefficients of the chemical equation. Now experimentally it has been found that rate does not depend, keep it in mind, does not depend on N, on N concentration term of A and M concentration term of B. That means rate, experimentally it has been found that rate of the reaction does not depend on all N, that is concentration of A, and all M concentration terms of B. That is, it depends upon some other terms. So it may depend. If it is, if I will write it is proportional to rate, I will write if rate is proportional to K, concentration A raised power, let it is alpha, concentration of B raised power beta. So here in the first term it was in accordance with the law of mass action. Now second term which I have shown here concentration, मोल concentration of A and मोल concentration of B, but powers जो हैं, powers मैंने alpha और beta लिखी. These concentration terms, that means alpha and beta, they have been observed experimentally. That means in order to find the actual dependence of the reaction rate, we have to carry the experiments to find on which concentration term it depends. So these alpha and beta have been determined experimentally. So this is called the rate law expression. This is called the rate law expression. This equation which I have shown here, it is the rate law expression. So I will write here again. For example, X times A plus Y times B plus Z times C gives products. Now, as per the law of mass action, first I will write law of mass action. It is rate is equal to K, concentration of A raised power X, concentration of mole concentration of B raised power Y, mole concentration of C raised power Z. Now, as per experimental evidence, जब हम experimental evidence के हिसाब से लिखेंगे, that means rate will not depend upon the concentration X, Y and Z. X is the concentration term of A, Y is the concentration term of B, and Z is the concentration term of C, as shown in the balanced chemical equation. These are the stoichiometric coefficients. So I will write, suppose the rate is equal to K, concentration term of mole concentration of A raised power P, mole concentration of B raised power Q, mole concentration of C raised power R. Now this P, Q and R, these which I shown in the powers, these are determined experimentally. That means this P, concentration term of A, Q, concentration term of B, R, concentration term of C, these have been determined. P, concentration term P, Q and R, these terms have been determined experimentally.